All right, so yesterday's stuff, the basic properties we had postulate 3.1. Okay, that was from what? Wednesday's material when we talked about postulate 3.1. That was based on corresponding angles. So I'm just going to kind of briefly abbreviate. So corresponding angles. So whatever picture you have, if you have parallel lines, right, and you have a transversal cutting through them. So here's my, these are terrible markers. So you have your parallel lines, you have a transversal cutting through them. The corresponding angles automatically have to be equal. That's what that postulate says. So no matter what angles you have, so let's say this is a 25 here, that number can automatically hop to its corresponding angle. Remember, corresponding angle, one's inside, one's outside. They're on the same side of the transversal, and they're not next to each other. So that 25 can be put down here, and you can put it right there. Okay, that's theorem, or that's postulate 3.1. Is there any questions with corresponding? Now that was something you had to do yesterday for that Google form if you were here, right? So you had to transfer that number down. You had to write down, what angle 1, 2, 3, 4, whatever it was. And I provided you one of the angles in the instructions. You had to bounce around the picture. Okay, so that was postulate 3.1. Now, theorems, we did we did 2 new theorems yesterday, but total we have 3 theorems up to this point. Theorem 3.1, this one we did Wednesday. Okay, it was called the alternate interior angle theorem. Alternate interior angle theorem. Alternate interiors are also equal. So on this particular picture, the alternate interiors on this particular problem would be these two. Those are alternate interior. They're both inside. They're on alternating sides of the transversal, the line that cut through the 2 parallel lines. And what this theorem says is they're automatically equal. So this 25 can hopscotch to here. Now, we talked about the proof yesterday. That was kind of what we spent, 5 minutes on yesterday, talking about why does that actually work every single time. Well, the reason why that 25 can hop to that alternate interior spot is because it can go vertical. That 25 can go vertical right through the little funnel system and set equal to right in that location. So that's called an alternate interior. It'll work every time. So now the other 2 interiors that I don't have marked on this picture, these are also the same. They're not 25s, but whatever this number is, that's the same digit. I think it's like a 155 in that case. All right, questions so far? Okay, that was the stuff from Wednesday. That was 2 days ago material. Now, yesterday's. I'm showing that's Alexis again. It is. All right. So, the next 2 theorems, the new ones we had yesterday. So we had theorem 3.2. Again, how they number theorems. The first digit's which chapter you're technically in your textbook, and the number that comes after the decimal is what theorem number you're learning. So this is the second theorem we're learning, right? This one was called the consecutive interior. I hated that term that they used. Consecutive interior angle theorem. Okay, I had a better word for that. I didn't like the fact that I used consecutive. We haven't had that vocab word. The word that I wanted you to write in on that one was same side interior. Same side interior. That's the term that I wanted you to have. Now, this is a rare one. In fact, I'm going to put a little star next to this one. Out of all the theorems we had up to this point, right? The properties, postulate, theorem 3.1, even theorem 3.3, the one we're going to get next, they're all equal. This angle is equal to this one. This one is equal to this one. This is the only theorem that wasn't. This theorem, that's why I put a little star next to it, said that your same side interior angles are not equal, they're supplementary. That's why I put a little star next to it. They're not equal, they're supplementary. So that means the same side interior. So let me get rid of this little arrow here. The same side interior angles are these two. Those are your same side interior angles, okay? Because they're both on the same side of the transversal, they're both interior, they're not technically adjacent to each other. Those are supplementary. They have to add up to be 180 degrees, no matter what. You add the two together, you set it equal to 180. So whatever this angle is, let's call this x. I can solve it by doing this, adding it to the other interior that's on the same side, and then you set it equal to 180. That's what it's telling me. Does that make sense? Okay, now most people can just guess at the number. You can like, oh, it's got to be like a 155. So that adds with 25 to make 180, right? Or you can just subtract this over, do a little bit of algebra 1, subtract the 25. 180 minus 25 is 155. And that's how you get it. Okay. All right. Questions on that one? That was kind of a rare one. All right, last one that we had from yesterday, the last theorem that we had was theorem 3.3. Okay, theorem 3.3. This one talked about alternate exterior. Alternate exterior angles. Alternate exterior are angles on the outside of your photo, okay, on this thing. So the exterior angles, they have to be on alternating sides of the transversal, and they cannot be physically touching. So I would say like this angle right up here, that's an exterior, and the alternating side, so the other side, but it can't be physically touching, and it has to be on the outside, would have to be this angle down here. Those are equal, so you can transfer the 25 down here. That's an alternate exterior. Questions with any of the properties you've had up to this point? Okay, now there is only one more theorem that we have in this chapter. It was theorem 3.4. I'm going to write that one down here in a second. So if you need to, let's get like these written down, like abbreviated drawing of it. Then we're going to look at a new property, and then we have some stuff we have to talk about for this stuff. Hey, what's up? Hey, I have Judah right now. She's in my room, so if you can kind of mark her. Sorry, my phone wasn't working. It was like turned off, so I had to like wait for it to boot up. So, all right, sorry. Thanks. She's coming down in a little while. She's finished my work here. So, okay, thanks. Bye. Okay, so those are, up to now, those were 4 theorems. So hopefully you have kind of the abbreviations written down. Make sure on this one you're noting that it's not equal, they're supplementary. They have to add it to be 180. I'm going to show you what we're going to do with this stuff today. Like yesterday, I kind of gave you a kind of very generic, easy problem on the Google Classroom question of the day, where it was a picture with a bunch of blanks, and I told you one of the angles, and you had to go find all the rest of them. So, because the angles bounce around the picture like you're seeing here. Okay, on that picture, what are all the missing blanks? What are all the values for the missing blanks?
155.
Every single one of them. Because the 155 can go alternate interior to here. That's an alternate interior hopscotches. Then it goes vertical or corresponding down to here. And then it can go alternate exterior up to here, or corresponding or vertical. They're all 155s. That's how it works. If you have one angle, you literally can find all of them on a picture. And that's what the Google Classroom question was from yesterday. Now, it wasn't that one specifically, but it was one like that. We had to name off all your angles. All right, questions? Okay, now, let's talk about the theorem, the new theorem today. All right. So, new theorem today. Theorem 3.4. This is the last theorem in this section. 3.4. if one line is perpendicular so I think it says if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Let you write that down. I'll explain it here in a minute. This is a rare case I kind of hinted at yesterday. So line is perpendicular to one of two parallel lines, then it's perpendicular to the other as well. Okay, so I'm gonna draw this. So we have two parallel lines. Okay, so hopefully you guys can see this. So there's my two parallel lines. Again, how your book denotes that, they use little arrows to note that they're parallel. And we have a line that is perpendicular to one of them, for sure. So, what does perpendicular mean? We've seen that word back in first and second unit. What do you remember? Perpendicular.
It's going to cross through.
It's going to cross through. Good, I agree. That's one of the parts. It's going to intersect, right? Perpendicular means it's going to touch. What else? I agree with that. What type of angle would it make if it intersected?
90.
90. So it's going to have this little box in the corner. It's going to intersect, number one, because that's what perpendicular also means, but it's going to hit at a perfect 90. Okay, so how the proof works, because again, it's a theorem, we have to show why it works, other than just kind of stating the obvious and whatnot. Here's the reason why it works. Number one, okay, we state what perpendicular means. It means that it has this little box in the corner, it means it intersects. It means that that angle is 90 degrees. Okay. All right. That's the definition of perpendicular. Now, this is the part you gotta kind of follow along. I'm gonna use the properties we learned the other day. Especially, I'm gonna use the postulate that we did. The postulate, corresponding angles. Postulates, again, a postulate is an assumed truth. We assume it's true, there's no need to prove because of the inherent simplicity of it. Like, it's so easy, in fact, that there's only one way to show that it works, and it's just using a protractor. Okay, so we have a 90 here. So I'm going to use that corresponding angle. So this corresponding angle would hopscotch down to here. And this angle would also be 90, because that's corresponding. If these lines are truly parallel, corresponding angles have to be equal, right? That was one of our stipulations we've had. So if that's 90, then what do you call these two lines here if that's perfectly 90? Perpendicular. So I can put the little arrow, and that proves the whole thing, right? Just the simple fact that the 90 can hop down because of corresponding, that makes this a 90-degree angle, which makes it perpendicular, which proves what I'm trying to show. I know it's super easy, I understand. Now, the reason I bring this one up, and the only reason why this is an actual theorem, is because this picture is the rare one where every angle up here is 90 degrees. Every single angle in this picture is the same number. It's not like that one where they're kind of a mixed bag or they kind of jump around. Every angle in this picture is a 90-degree angle. Because alternate interior, vertical, the two same side interiors have to add up to be 180. So the only way that these two add up to be 180 is if this is also 90 degrees. Then it would hopscotch to here because of vertical, it would go corresponding, it would go alternate interior, and you see how every angle's 90. Like they're all the same number. So that's the rarity. I think that's the only reason why that theorem actually exists, to be honest. So, because it's there's no reason to have this printed because it's just dealt with that. It's just the same postulate, it's just corresponding. But I think that's the reason right there. Okay, questions with the new theorem. Okay, let's get to the stuff that I want to talk about today. Because obviously this is important, right? This is what we're doing. I want you to be able to transfer angles around the picture. But we have to do something more specifically with it. This was all fine and dandy, it's nice and easy. We have to do something more rigorous with it. What I want to be able to do is, let's get rid of all these markings. So again, these lines are supposed to be parallel. Sorry for my terrible artistic talent.
Straight lines are really hard to draw probably.
Yeah, especially parallel. All right, but here's the type of problem that I want to be able to solve. And that. I want to solve this problem and find the numbers. In fact, I'm going to make this a little easier. Let's just make that a y instead. Let's just make it easier. Okay? All right. Here's the idea. The type of question you're going to see in the homework today. Yes, you're getting homework today. It's like 7 questions. They're going to look like this. They're going to give you a picture, a bunch of parallel lines. They're going to have some variables. And the question says, find the missing variables given the parallel lines. So we have a bunch of parallel lines up there. So what you have to be able to do is use the properties we've discussed so that you can set up your algebra equation and solve for x or solve for y. So there's certain angles up there that should be equal to each other. So you set them equal and you solve. Or there's certain angles that should add up to be 180 or something like that. You have to solve one letter at a time. Does that make sense? And it doesn't matter which letter you start with. It just, at some point you have to be able to solve for one and then you can go solve for the other. Question?
Wouldn't 10 and 2x minus 30 be the same?
Yes. So, just like that. Like you notice that one of the properties works because you notice the alternate interiors, right? You notice that this angle should be equal to this one. Set them equal, solve it. That helps you find x. X will be a decimal, it could be a positive, negative number, it doesn't matter. So I would set the 2x minus 30, I would set it directly equal to 10, just like you said. They're equal angles. And then I solve for x. Okay, so yeah, I would add this across to make 40, right? Because when you drag that constant to the other side, it becomes the opposite. And then you divide by 2, and absolutely right, I heard somebody even say it, the x was 20. Fine. Cool, don't care. Move on to the next letter. So now, what?
Wouldn't the 10 and the y plus 5 be the same too?
Yes, why?
Because of the,
Funnel.
Yeah, vertical, the funnel.
Yeah.
Yeah, you're absolutely right. So that's something you gotta notice, right? This angle should be the same because the little vertical angles, right? They go through the little funnel system. Those two angles should be the same. So again, I would set those equal to each other. Just like you said. And then solve for y. So subtract the 5 across, and my y turns out to be a 5. Done. I have both letters, and that's what I want you to type in your Google form. Hit enter, move on to the next question. Does that make sense?
yeah.
Now, there was another way I could have done that problem. There was another way I could have done it. I'm not going to try to confuse you with that. I want you to be able to look at a picture and find the easiest way you can to set it up to solve for one letter at a time. You don't need to think about it. Don't overcomplicate the picture. Just if you notice, okay, alternate interiors are equal. Set them equal, go solve. One letter at a time, though. Don't try to do weird stuff where maybe there's 2 different letters going on and you're like, oh, I have 2 letters, how do I solve? You should think of something different. Don't always get stuck with alternate interiors in your head, or don't always get stuck with vertical. Like, you have other options to pick from, right? They could be same side interiors, so they have to add it to be 180. Or maybe the alternate exteriors are equal. You can set those. You should be able to solve every single problem with one variable at a time. One variable. Okay? Does that make sense what we're doing? Let's do 2 more. I want to do 2 more of these and then we're done for the day. Okay? So let's do one that's a little more challenging than that. All right. All right, so one that's just a hair more challenging. You got new markers, these are dying.
Some black over here.
Yes, sir. Throw that. Throw it, launch it, just launch it. Yes. Dropped it. All right, let's see, please work. Oh, it's way better. It's way better. There you go, get new markers. Okay. So we got my parallel lines. I'm gonna set some stuff up here. Let's go, this is a 2y, this is a 3x plus 10, and this is a 2x plus 5. Ooh, now we're in difficult town. Okay, question.
Are they all equal 90?
No.
I can't see it, so I'm
Yeah.
just asking.
Yeah, so it looks like 90. We don't assume it unless they put a box in the corner. Unless they put a box in the corner, don't make them 90s. So that's a good rule. Good thing you bring that up. Okay? Not 90s, because we can't assume that. But, and now you're looking and you're like, Ward, I don't have a number, right? It's not giving me like the 10 like earlier. You have to think outside the box a little bit. Like, what are these two angles called?
Same side interior.
Same side interior, right? That's this one right here. Right? Same side interior. They have to add it to be 180. To add these two together and set it equal to 180. Now I have a number to work with, right? So adding these together, this makes 15 and 5x, right? Add the x's, add the 10 and 5 together. I'll subtract this across, so I get, what is that, 165? And then divide by the 5. So divide by 5, divide by 5. Remember, you always add and subtract first, then divide last. And so, what is that? That's a 3, carry 1, that's a 33 maybe? Let's see, 3 is 15, 1, 3, 33. So maybe with the calculator, double check. That has one. Oh, I do have my calculator. What do we got? 165 divided by 5, 33. Okay, so now, I found my x is 33, right? How does that help me? Because I still have y, right?
You can use like the 2x plus 5 and the 3x plus 10 and put the 33 for x, and then you can do like the 2y corresponding to the 2x plus 5.
Exactly. So on some of the problems, it's actually saying you might have to take whatever variable you have that you found, right? You found x is 33, right? We did it. You might have to go plug it back in so that I can actually transfer that number around. So that's something that they don't tell you to do. So you might have to take that 33 that we just found for x, plug it back in, and I can plug it in both spots, it doesn't really matter. This turns out to be 66 plus 5, which ends up being what, 71? So that angle is 71 degrees. And then we would set this angle corresponding to that one. Those should be the same angle. So the 2y should be equal to the 71. You're going to get a decimal. It's going to happen. You're going to probably have decimals today. Divide this, dividing that, what is that? It's a 3, 5.5.
Yep.
So there's my y. Thanks, Jada. Just put it on my desk there. Perfect. All right, see you third period. Okay, questions? Okay, last one today, last one. Let's put it over here. So last one. go with, okay, 4x plus 10, and let's go with 5x minus 50, and I want a y plus 3 here. My last one. Okay, now notice on this one again, I didn't tell you explicitly, you know, a number up there. I didn't tell you like, oh, there's a 10 degrees or there's a, you know, a 20 or anything like that. Like, we have to figure it out. So, and you should always solve one letter at a time. Don't think that you have to set two weird different variables equal to each other. It's probably not what you're doing. Okay? So on this problem, what do we know about that picture currently? What do you got?
The 5x and minus 50 is the same as the 4x plus 10.
Good, I agree with that. Now, why do you know that? This is true. These are both equal to each other. Why?
Alternate interior.
Yeah, it's this theorem right here. It's theorem 3-1. The alternate interiors are equal. They have to be set equal to each other because of alternate interiors. So that's something you have to be able to notice when you first look at a picture. Are there certain angles that are equal? Can I set them, or do I have to add them up to be 180? You have to know. Are they same side interior, alternate interiors, or alternate exteriors, or something? So I'm going to solve this. Right? I don't care how you want to do it. I'm going to subtract the 4x this way and add the 50 across. So subtract the 4x. This makes 1x, which is just x. I don't need the 1 there. And this makes 60, so my x is 60s. But then what do I do?
Plug it back in.
Plug it back in, because I need to go find y. I don't care where you plug it in. Maybe you want to plug it in here and do the corresponding thing like I just talked about earlier. Right? I could do the same thing I just did earlier, or yeah, you could plug it in here. You could take this, you know, this, what is that, 60? You could plug it in here, and then go set it equal to the other side because it's vertical. So I'd set that in. My numbers don't make sense here, but just go with it. 60 plus 10. So this turns out to be 240 plus 10, which is 250. Not really a real number, and then set equal to that. So the 250 is equal to y plus 3. So this ends up being like 247. Y plus 3 is equal to 250. Subtract the 3 across, and your y is a 247. Not a real number, but angles usually don't go more than 180 here. Questions? Okay, I think your Google question went live about 7 minutes ago. So it's 7 problems. You have to solve for x and y. All you're going to have to do is type in, you know, x is this, y is this, go to the next question. You might want to put your work on a separate sheet of paper. You don't have to submit the separate work. You're just going to have to submit your answer. Be careful because the questions are random again. There's a big pool of questions I've picked from. I think it's only going to ask you 7. So don't feel like you and your neighbor have the same question. You probably don't. So just be aware of that. Make sure you log in with your Google or your GHB school account when you're doing it. Otherwise, I don't know if it will show up correctly. Alexis, you are good to go. You can go answer Google questions.
To answer, we do like y equals 20 or whatever, right?
Yeah, you just type in y is this, x is this, or z is this, whatever variable it gives you.
Okay.
Yeah. And they could be decimals, negative numbers, it could be some weird stuff you're gonna get, so. These problems are pulled from random textbooks I have. So. This assignment is due on Tuesday next week. So don't feel like you have to get it done today. It's due on Tuesday. Gives you a little bit of time to figure out what you're doing. If you didn't answer the Google question, maybe you were gone yesterday, you can go back and do that today. So, we were missing a few yesterday, like Smith and Gouge, you were gone. So, yeah, Gouge got your email last night at like 11, sorry. I was going to answer you at 11. I figured you were probably sleeping by then. Yeah, which way to go? Okay. And then you start bouncing around, like, so just go vertical there, and it can go like corresponding up to here, go vertical there. That makes sense.